Hello and welcome to EC Electronics. Today's video is ISRO Technical Assistant Mock Test Series Part 24. So we are going to see the 10 questions for ISRO Technical Assistant Examination. I really hope that you will be finding the questions useful. If yes, please don't forget to like, share and subscribe. Now let's see the 10 questions. Now we are going to see the solutions of the 10 questions for ISRO Technical Assistant Mock Test Series. The first question is, diffusion current is due to dash. A. Applied electric field over a given distance. B. Variation in carrier concentration. C. Random motion of holes. D. Recombination of holes and electrons. So we have discussed about the diffusion current and the drift current. Diffusion current in generally also, diffusion is due to the concentration variation, and hence the diffusion current is produced due to the variation in carrier concentration. So the correct answer is option B. Okay, so diffusion current is due to the variation in carrier concentration and drift current is due to the applied potential. Okay, so diffusion current, these are the two major currents, diffusion current and drift current. Diffusion current is due to the carrier concentration variation and drift current is due to the external potential applied. Okay, so the correct answer for first question is option B. Second question, you can see the questions on board. Second question, ripple factor of half wave rectifier is dash. A 1.414, B 1.21, C 1.3, D 0.48. For half wave rectifier, these type of question, the ripple factor question is very important. Even though they are theoretical questions, they are highly repeated. Okay, so the ripple factor for half wave rectifier is 1.21 and for full wave rectifier is 0.48. Okay, so here the correct answer is option B, 1.21 is the correct answer. Moving on to the third question. The overall gain of multiple amplifiers in cascade can be expressed as dash. The individual gains are A1, A2 and A3. So when we cascade the amplifiers, the overall gain will be the product of individual gain. Okay, so that is the equation. Overall gain is equal to product of the individual gains. So A1 into A2 into A3 up to n numbers. Okay, so here there are only three amplifiers, A1, A2 and A3. So the correct answer will be option D, A1 into A2 into A3. Okay, so that is a general concept. When we are cascading amplifiers, we are actually we want to increase the gain. That's why we are cascading, and hence the overall gain will be the product of the individual amplifier gains. Correct answer here is option D. The fourth question, moving on to the fourth question, you can see the question on board. Okay, the question is from Wien bridge oscillators. At resonant frequency, what is the phase shift for the output in a Wien bridge oscillator? So we know that in a Wien bridge oscillator, so the oscillators generally consist of an amplifier session and also there is a feedback. So in the case of a Wien bridge oscillator, this will be a Wien bridge circuit, right? Now this Wien bridge feedback circuit is used for producing some phase changes or phase shift in your output. But the question is little bit tricky. At resonance, what is the phase shift for your output? Resonance means there is no phase shift. So at resonance, the phase shift will be actually 0 degree. Okay, correct answer is option A, 0 degree. And if the question is what is the element which produces the phase shift, means that will be the Wien bridge or the feedback circuit which is given by the Wien bridge circuit. Okay. So here the correct answer is A, 0 degree, since at resonance the phase shift is 0 degree. Okay. Moving on to the fifth question. The fifth question is from op-amps. Lot of questions can come from the characteristics of op-amps. Okay. Fifth question. In an ideal op-amp, which is not true? Op-amp, option A, open loop voltage gain is infinity. B, input resistance is infinity. C, slew rate is infinity. D, CMRR is 0. Correct answer is option D, CMRR is 0. This is not a correct option. CMRR has to be infinity. Okay. So our aim is to pass or promote the differential mode signals and not the common mode signals. So the common mode rejection ratio should be infinity. So that is a basic principle of an op-amp. And also the other options are actually the other characteristics of ideal operational amplifier, which are open loop voltage gain is infinity. Yeah, that is correct answer. The correct option. B, input resistance is also infinity, whereas output resistance is 0. Also, slew rate is infinity. And the correct answer for this question is CMRR is 0, because that is a wrong option. Okay, correct answer is option D. Moving on to the sixth question. Sixth question is from semiconductors. In which of the following semiconductor the concentration of the holes and electrons is equal? Okay. Now the options are A, intrinsic, B, extrinsic, C, compound, D, elemental. This is a little bit confusing type of question because there are elemental, compoundal also. But we have studied about the intrinsic semiconductor, its characteristics. Okay. So in intrinsic semiconductor, we know that the number of electrons is equal to number of holes, and thus we consider that they are pure form of semiconductors, and then we add some impurities into it and we make a variation in the concentration of carriers, that is the holes and electrons, and then we produce extrinsic semiconductors, right? So here the question is, in which of the following semiconductor the concentration of electrons and holes are equal? That is in A, intrinsic semiconductor. Okay, so that is the correct answer. Moving on to the seventh question. Seventh question is from network analysis. Find the current I3 in the circuit shown below. Okay, so I'll draw the circuit for you. So there's a voltage source here. There is a resistance. There is another resistance here. There is another resistance here. So this is 5 ampere. This is 2 amperes. This is I3. You need to find that value. Very simple question actually. So what will be the value of I3? You can see that in this node, the current splitting is happening. 5 ampere current is coming to the node. 2 ampere is going through this branch. And remaining will be 5 minus 2, which is equal to 3 amperes, right? So the I3 value has to be 5 minus 2, which is 3 amperes has to be your I3 value. So correct answer is option C, 3 amperes. Now moving on to the eighth question. Which of the following is true about an ideal voltage source? So this question is from electronic instrumentation and measurements. Which of the following is a characteristics of ideal voltage source? A, zero resistance. B, small EMF. C, large EMF. D, infinite resistance. So for a ideal voltage source, we consider that its resistance or input, its internal resistance we don't generally consider because we take it as 0. Okay, and we consider that the voltage is directly proportional to current, and the resistance we take as 0, R equal to 0. Directly, it is linearly varying voltage. That is, the current is linearly varying in accordance with the voltage we take. So, the resistance we take as 0. So, we don't consider any internal resistance for an ideal voltage source. Okay, so that is the concept here. And for that reason, the correct answer is option A, 0 resistance. That is not small EMF, large EMF or infinite resistance. For an ideal voltage source, we take 0 resistance. Correct answer is option A. Then, 9th question is from communication systems. A 2 MHz carrier is amplitude modulated by a 500 Hz modulating signal to a depth of 70%. If the unmodulated carrier power is 2 kilowatts, the power of the modulated signal is dash. So the question is explaining various things. The carrier frequency is given, also the modulating signal frequency is given, but we need to find the power. So we don't need frequencies. Also the carrier power is given, which is PC equal to, if the unmodulated carrier power is 2 kilohertz, means PC is equal to 2 kilo, not hertz, it's watts. 2 kilowatts is PC. Also, modulation depth is 70%, means modulation index M will be 70 by 100, which is equal to 0.7. Okay. Now, if you have these two things, you can find the value for total power of the modulated signal. The power of the modulated signal PT is equal to, the equation is PC into 1 plus M square by 2. Directly substitute the values for PC and M and you will be getting the answer. Okay. If you substitute, right, after removing this, okay, so I need to find PT. PT is equal to 2 kilowatts into 1 plus 0.7 square by 2. If you solve it, the value you are getting is 2.49 kilowatts. Okay. But in the options, you can see A 2.23 kilowatts, B 2.36 kilowatts, C 1.18 and D 1.26. So this is actually a small change in your options. So the closer values will be we'll select. That is option B, 2.36 kilowatt. We can select as the answer. Okay. So these type of small variations can come. In that case, you have to select the closest value. Okay. Here the answer will be option B, 2.36 kilowatt. The last question, which is question number 10. Which of the following parameters can't be found with Hall effect? A. Polarity, B. Conductivity, C. Carrier concentration, D. Area of the device. Okay, so the Hall effect is actually connecting the EMF produced across the conductor when it is placed in electrical and magnetic field, and its relation with the EMF and its relation with the electric field, magnetic field and the current passing through it. Okay, that is Hall effect. And it has nothing to do with the area of the device. So we cannot find area from this Hall effect or its parameters. Okay. So correct answer here is option D, area of the device. Okay. So 10 question correct answer is option D, area of the device. And these are the 10 questions which I have included in this video. I really hope that you found the questions useful. If yes, please do give it a thumbs up and also share it with all your friends who's preparing for technical assistant examination or any competitive examination. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.